everybody. It is good to see you. A lot of people I know get to Sunday morning. Oh, by the way, guys are cute. A lot of people get to Sunday morning and they're like, give me the flight, I'm out of here. So I am so happy to see everybody here. It's wonderful. Wonderful stuff. So look, just some introductions here. We're going to do this thing called Advanced Persistent Pentester. Don't you like it? App, TM, right? And we're going to try to cram 3 talks into 45 minutes, okay? Which means we're probably not going to do each section as much justice as we would like to do, let's be honest. But we'll do it anyway. So right here next to me are my fellow colleagues at Black Hills Information Security. Give it up for Beau Bullock and Derek Banks. My name is Joff Thayer. Some of you may know me. Who's a Security Weekly fan in the audience? Oh, yes. Love it. Okay. So there's the alphabet soup. We pen test things. We break things. We do Security Weekly on a regular basis, except this week. Well, somebody might have done it. Beau likes to do Hack Naked TV, which is really awesome. Yeah, we are nice people. We like what we do. We have a good time together. We break things, all right? So who's winning? This is a slide out of the SANS Incident Response Survey earlier this year, and it's pretty obvious what the trends are between 2015 and 2016, right? We're talking about unauthorized access, big data breaches. We're talking about an uptick in unauthorized privilege escalation, and we're talking about crafted malware, right? We're not talking about exploitation anymore. This is about custom-crafted, targeted malware. So let's talk about that. Right? Traditional pen testing, yeah, traditional pen testing. Let's vol scan. Let's exploit the highs and criticals. Let's escalate, pivot, grab a beer, celebrate, done, right? How many times anymore does that actually work? Right? Not as much, right? Maybe in some environments where people are just not securing things, this traditional kind of approach works great. The highs and criticals are all there. You grab stuff, you pillage, rob, steal, take data, go home, write up a pretty report, and everybody's happy. But really, are you doing the organization a service? If they're more mature and they're actually patching things, you may not find any highs and criticals. More than likely, you won't find any highs and criticals. So we've got to try harder. It's not just about the traditional approach, rinse, lather, and repeat. We need to go deep in some cases. And when we go deep, we need to think in terms of developers and think like it's 1999 again, like old school hacking. Forget about just the traditional methodologies, right? Go into a goal-driven mode. Explore those informational low and medium findings, right? Test our defenses scientifically. Like, be really rigorous about this, right? We obtain and demonstrate access to sensitive data. We might not even need to escalate in a pen test. What's it really about for the customers, right? It's really about us demonstrating that they have business risk. Do you always need domain administrator to demonstrate that, right? You don't, okay? You don't necessarily have to. You can demonstrate business risk in so many other ways, right? So the point is, this talk is the app FOO, Advanced Persistent Pen Testing FOO. Don't just use the training, invent new things, right? Let's invent new things. Let's talk about the fun and frustration of inventing new things and sort of going off the reservation from traditional training. So here's the agenda. I'm going to start out by talking about some Java serialization and deserialization work. I've actually, up to 2 0 days I've found this year in pen tests. One night we can talk about it. If anybody was at John Strand's talk yesterday, was talked about. The other one, I cannot talk about. But I'll talk about it in sort of generalization terms, right? Derek's going to talk about a black box case study as part of a pen test. And then Beau is going to bring you some goodness that you're going to love. I promise. Beau likes to release tools. So Beau's going to release some stuff that's really going to be awesome. But I won't steal his thunder. And we'll let Beau do that. And then we're going to cap it off with some summary and conclusions. So that sounds like fun, right? We ready? Yeah, let's do it. All right. So Java serialization and deserialization. Here's the thing with Java. It likes to serialize objects everywhere. And it likes to transmit them between clients and servers in serialized form. Okay? can be a very bad thing, okay? Couple of things here. First of all, it'll serialize remote method invocation. It'll serialize that over whatever custom communication methods it wants to. It will also serialize that over HTTP or HTTPS traffic. And there is a lot of implicit trust built into serialization and deserialization, okay? What you have on the screen here is a simple Java program. Don't hate me, I am not a good Java programmer, okay? It's a very simple Java program that is a serialized test object, okay? Has my name in it as a couple of attributes, and then I wrote this object out to a file. That is a serialized object. It can be stored on disk, it can be transmitted across the network, and when it's received at the other end, it will be deserialized and a new Java object will be created. Sir, in the back, we see this. The question was, how often do you see this in Java applications? All the time. It is endemic in Java applications that are splitting into client-server entities. It's everywhere, okay? What's the problem with this? Well, let's talk about reading the object first. We'll talk about what the problem is in a minute. So here I read the object back. Very simple. I've got a class here that is creating a creating an object, reading that binary blob from disk that I just wrote in the last program, and then just printing out the attributes, right? So all I've got there is two programs, one that writes to disk of the object, one that reads it back, okay? Pretty straightforward. Right. Here's what you might see when you have serialized objects going across the web, okay? This is straight up Burp Suite, okay? First of all, if I XXD my new little object, new thing.ser, I see some interesting stuff here. I see ACED0005 as the first bytes. That is actually the magic byte string to indicate to you that you're dealing with Java object serialization and deserialization, okay? You will see that if it's over HTTPS inside of Burp or other favorite interception proxy, because if you just debug the raw format, you're going to see ACED0005, okay? That is a Java serialized object coming over the network. Nice. So what can we do with this? Well, first of all, we have a couple of input-output classes. We've got Java.io output stream. This thing has some very simple methods that write serialized data to an output stream. Write object, write char, write short, and various other data structure methods. There's the equivalent Java.io input stream. Read serialized data, read object, read char, read short, okay? There is no sanity checking in these methods in Java. If you read the object, it will get read and created from a stream, okay? Unless the developer actually puts in specific code to check for things that are good or bad, okay? Now you can see where this is going, right? So we discover them by seeing it in HTTPS content. We're going to see 0xAECD0005 in the content. And the things that can go wrong is the object input stream class does not check which classes get deserialized. Okay? There is no whitelist or blacklist object checking unless the developer implements it and overrides the read object call, right? The user split input is likely going to be trusted, right? And what I found in some recent tests, client-side objects are often trusted completely with no validation at all on the server side. Right? So how am I going to know what the object data structure actually looks like? It's easy for me to stand up here and say, hey, here's a Java serialized object that I created in Java, right? But if I'm dealing with an application that I'm testing, I need to know actually what that code looks like outside of the context of I wrote it, right? Java decompiler is your friend. So JD GUI, I just did this with my own class, okay? So let's imagine you're testing a Java application. It's serialized and deserialized. You spot it in Burp. You know it's a Java applet that pops up when you first use the application, okay? Download the class. Download the jar file, right? Unzip it, run it through Java decompiler, and in most cases, save the source code, okay? So you can reverse it. Once you've saved the source code, you can then go through it and specifically search for things like object input stream, object output stream, read object, and write object. Okay? If you find those things, look deeper. There's likely to be deserialization vulnerabilities in that application. Okay? Here's some methodology thoughts that I put together, and I'm telling you, I'm giving this a really lightweight treatment, okay? Because we don't have too much time. If Beau shows you the magic bytes, 0xAECD0005, okay? And you see things like post requests to /XYZ magic servlet, then you've got Java object serialization in play, okay? Couple of things you can pick up. Go ahead and grab Super Serial Passive. Very useful little plugin that you can get into Beau from Direct Defense. Okay, get that in there. You'll at least see the alert. Look for the Java's deserialization scanner in the B App Store. That's a useful thing to have to at least try to manipulate those objects. There's not much comprehensive coverage with these tools yet, though, so you've got to be careful. Download the applet directly. Absolutely decompile. Search for read object and write object. In particular, locate the serial version UID field, because most objects will not get deserialized and created back on the server side unless the serial number is correct. That's the only check that's there. But guess what? You can just pull that out of the string, right? It's not a big deal, right? Then find your object classes, write proof of concept code that creates the objects directly on disk, compare the objects with some sort of binary diff until you get it correct. Change values in the object, remove fields from the object, add fields back to the object, fuzz, hack, profit, create brand new objects if you can. Okay, there's all kinds of things you can do here, but you just have to get into being able to write some basic Java, being able to decompile the Java, and then start to manipulate the objects in the string. Okay? So here's some resources. First of all, what I'm talking about is a real zero-day case that happened for me this year. I'm not going to mention names, but the short version of the story is there was a servlet on the server side of the application that trusted the path name sent from the client object. What could go wrong with that, right? The result, I could read any file from that server, not just any file in the server's Java servlet object path, any file from that server, okay? One thing that's talked about before, first of all, this topic hasn't come up too often. In 2015, there was a couple of talks. Matthias Kaiser in one of the German conferences did a talk here. There's a YouTube link. Take a picture of this if you're interested in pursuing this further. There's also the Apache Commons Collection Library, which is a known vulnerability that was discovered by the guys that write Waisu Serial, which if you're in here, and I apologize, I don't know your names. But Waisu Serial is the last link here that helps you exploit that one. This one is particularly pernicious, okay? What happened here is they found a way to gain remote code execution by serializing an object back against the Apache Commons Collection Library in multiple applications. There's a serious problem here in that you would think, hey, I can just go patch that, right? If you've dealt with Java server-based applications, what happens is you can have 5 or 6 different applications that you have put on this server that have 5 or 6 discrete separate copies of the same class path libraries. It's not like patching OpenSSL or SSH or something. You have to find every one of them, okay? Very serious problem. So Waisu Serial in the Apache Commons Collection Library is widely used and really vulnerable. Remote code execution possible. Okay. At that, I'm going to leave it and move on to our Black Box case study because I'm taking up too much time. Here's Derek.
Thanks for a great conference so far. And I'm going to switch gears a little bit and I'm going to tell a story. This story is an engagement that Beau and I were on earlier in the year. And thank you. So this black box test we had a client who wanted us to start with their domain name only and get into their internal network. They went as far as to put a flag on the internal domain controller, and they gave us a week to do it. So, challenge accepted. So, how would you go about getting in? Well, the obvious thing, phishing, right? We'll start with phishing. And we got some good targets. We thought we had some good ruses, but it just wasn't really working. Turned out they were really catching our campaign as spam, as junk. Couldn't get it through. We ultimately did get one shell, and we were able to start doing a little bit of situational awareness inside of the network, but then the shell died. We later found out that the user actually took a long weekend. This was like on Wednesday of the week. So we're getting a little concerned. I mean, we don't like to lose, right? So we noticed during reconnaissance that their MX record pointed to an auto-discover domain. That auto-discover domain was in the Microsoft Azure cloud. So we started password spraying. And at first, the password spraying wasn't working. In the sake of brevity, we did get password spraying working. If anyone's interested in how we went about doing that, we ended up bypassing a protection in the Azure login process. So we were able to access multiple email accounts. And if you have your email in a cloud provider and they're telling you that there are safeguards in place for authentication, you may want to double check what's actually happening during the authentication process, because it may not be an adequate substitute for two-factor authentication. In fact, in this case, it definitely was not. So we got into the email. Then we were able to get the address book and get every, not just the ones we had during reconnaissance. So we went from 700 targets to like 3,000. And we started using passwords other than summer 2016, spring 2016. Turned out company name 123 was a really popular one. So we started reading everybody's email. We soon found out that they had SharePoint in the cloud. Did that have two-factor authentication? No, it did not. And so with access to SharePoint, there's a search feature in SharePoint. So now we're in the email, we're in SharePoint in the cloud. So what would you search for in SharePoint? We searched for VPN. Yeah, turned out they had instructions for how to VPN into their network in the SharePoint cloud. And then on top of that, they provided a download link for the client. It's very helpful. So we installed the VPN on one of our systems, and we were able to connect into their internal network. Then we found a clear text administrator password in a sysvol share. Found a place to remote desktop to with that administrator account. And from there, well, mimicats, rinse, and repeat. Soon we found the flag. So the point of all that was, sometimes traditional things won't work. And then getting into, or after the traditional things don't work, actually taking a look at what's happening during the test and being a little creative went a long way here. And the other point to it that I would like to make is that access to email is something that we tended to overlook. And we had many conversations about how valuable email is. And every company, everyone sends all their data in email, right? You just assume it's internal email. It's trusted. Attackers can't get into that stuff, right? Well, I'll let Beau tell you about that.
Thank you.
We got a question back here?
Oh, yeah.
Just two quick questions. Do you know what the administrator password, what they were using that for in the bat file?
I'm sorry.
What was the administrator password in the bat file? What were they doing? What task?
Yeah, that was widespread local admin across all their clients and servers.
But in the bat file, what were they utilizing that for?
Yeah, they were setting it. They weren't using something like Flaps or, yeah, they were basically setting it.
Dear Pentester.bat?
Pretty much,
Yeah. I think that was actually the name of the file. Please don't look here.
We ended up leaving a file on their domain controller that said VHS was here, just to close it out.
They had a flag, so we had a flag.
Yep.
So were they federated? That's why you were able to use the creds you got from.
You know, I do not know the answer to that.
So,
I would assume that they had, so it was tied to their internal authentication. So their domain accounts were working across the board for the stuff that was in the cloud and then the stuff internally as well.
And what's kind of unique about that one too is, you know, in a lot of the external tests we do, we find VPN services running externally pretty often. This case, we actually, during our initial recon, didn't find where their VPN stuff was.
I mean, the attack surface area is very slim.
Very
I mean,
slim.
it was auto-discover, their website with brochureware. I mean, obviously they had taken some kind of level of, hey, we're going to lower our attack surface.
And typically you could, you know, find like vpn.domain.com or remote.domain.com or whatever. That was not the case to this one. But having access to SharePoint, we just searched for VPN, and sure enough, here's a third-party service they were using, and the key to access it is, yeah, it's ridiculous. All right, here we go. All right, so their talks kind of lead into where I'm at. So, you know, at the point where you get domain admin on a network now, which, if there's pen testers in the room, which I'm sure there are, you guys know it's not hard on most customers. It's a pretty simple, straightforward process, especially with like Bloodhound now. I mean, dude, it makes the process of pivoting around so easy. You know, with Bloodhound, if you're not aware of it, it will go out to, you know, all the systems, enumerate all the group memberships, and help you find that escalation path. So if you have like one credential on a network, you can now figure out your escalation path to domain admin with a simple script now, which is beautiful. So, is domain admin enough though? Are you on your pen test just looking to get domain administrator access? If that's the case, you're doing it wrong. Most C-suite, all the CEOs, CIOs, they don't care. Like, yeah, you got domain admin. What does that mean? You know. But if you go to them and you say, hey, I was able to actually access all of your customer data, or hey, I got access to your industrial control systems and I'm an admin on them. I could shut down the power for a city. That means something. So how do you go about finding that stuff? One of the things that, you know, I like to point out is that last year, Mandy and M-Trends released a report that said that it takes 146 days on average to detect an attacker in your network. We don't have that long on pen tests. We have 5 days, maybe, right? So simulate the same level of risk that an attacker who has that amount of time can get access to on a network. You have to do it fast. So you're noisy, but being able to do it matters. And a lot of times, if you know nothing about an organization, how do you go about like learning more about the internal aspects of what they do day to day, where they actually have the data on the network? A lot of that can be really tough, right? So one of the things we use a lot is PowerView from Hardroid, which has a few modules built in to find sensitive data on a network. So one of them is ShareFinder, which basically will just go out to the network, find all the network shares that you have access to. You know, you run that as a domain admin, you find all the shares on the network. And then there's another function that Hardroid built that basically just looks at the names of files for specific terms. So, you know, finding passwords in documents, you know, we'll run it and get like, you know, a ton of like where users have just straight up put like passwords and text files on the network, which that's cool. But what if you're on a network that's really large and, you know, maybe there's, you know, a ton of different, or maybe there's not enough data there to help point you to the exact right place. Another thing, you know, target databases. So like just straight up going after databases, which, you know, you can query Active Directory for the SVN for MSS SQL servers and just go straight to target them, or even what I like to do is get access to like a vCenter server. And at that point, you can just like see where your awesome admin has already like categorized everything into a beautiful list. So like here's our Exchange servers, here's our SQL servers, you know, here's all our AD infrastructure. If that's the case, then you know you just drop right down. And the cool thing about vCenter and any virtualized environment is that it's kind of a false sense of having segmentation on a network. So a lot of people think like, oh, I've got this critical server locked down. I can only access it through RDP on this one jump host at 5 p.m. on a Friday. And you drop into vCenter and you have console access to everything and completely bypassing all those restrictions, which is pretty cool. So we started talking like, what else could we do to locate sensitive data quickly on a network? Is there is there anything that would help point us in the right direction? Trying to, like I said, in 5 days, learn as much as you can about the organization is tough. So the thing we kind of came to the conclusion of is email. Email is the primary communication platform for pretty much every organization. So if you're an employee at an organization, you inherently trust your internal email. You send things on a day-to-day basis to everyone. You don't. Typically, most employees don't have that mindset of, oh, I'm sending something sensitive in an email. That's bad. We see like general chit chat, just internal emails back and forth between people, and you also have like password resets. Got people talking about just day-to-day business. You might have your C-suite just basically like doing their critical business over email, saying, hey, we're increasing the budget here or whatever, or we need to implement these new systems to do X function for the business. So what I did is I wrote a tool to search everybody's email on a domain. So I'm introducing Mail Sniper. It's a PowerShell script that once you have elevated in a domain now, you now have access to search everyone's email on the domain for specific terms. In the same way that PowerView searches the network for shares and files that have specific terms, now we can search everyone's email, the body, the subject, and so there's a couple functions within Mail Sniper. The first one, once you've escalated, which you have to have an Exchange administrative account. Domain admins, by default, actually don't have the ability to search everyone's email on a domain. So Exchange is, you have to specify who can actually access people's email. Exchange administrators, either organization management group or the Exchange organization administrators group inherently have access to do that. When we're looking for elevating now, we don't typically have to go after DA specifically. You can go after Exchange administrators and now search everyone's email for passwords, find insider intel, look for databases, like where somebody's talking about a database on a network, anything. Like if you wanted to search for, let's say like industrial control system or ICS or SCADA, you're going to get a full list of just all these emails that where the inside of the organization was talking about this specific thing. So it's on GitHub now. The other thing too is, so with it being a PowerShell script, I wrote it under the idea that I wanted to do it all from a testing system. Typically, if you're running PowerShell Empire, you got a session on like a workstation in the environment. This is where you would be able to run it from. So you don't have to actually get access to the Exchange server itself. You can just run it from any workstation via PowerShell and connectivity to the domain. So there's two functions, like I said. When I started writing this, I thought, yes, looking at everybody's email is really awesome. But like I said, it does require administrative access. But what doesn't require administrative access is searching your own email, which, if you have access to a system, you can always search your own email, just pop open Outlook or whatever. But using Exchange Web Services is basically what I'm using to connect to Exchange. Exchange Web Services is basically the web-based API that is installed on Exchange servers by default. So now, with my tool, you can, as long as you have credentials, valid credentials for a user, you can now search their own email. So why would that be important? Why would being able to search any particular person's just, their own email, why would that matter? So a lot of times on engagements, we get a lot of creds. Password spraying, running Mimikatz on random hosts, but maybe we haven't escalated to DA yet, but we have a bunch of creds. Now all you have to do is run command terminal as any of those users, and you can search through their own email for passwords. So it becomes another privilege escalation vector now. So we don't have administrative access, but we have some creds on the network. We can search their email. For example, I actually ran this on engagement last week. And I just searched for a database. I was looking for a customer database. And it came back a lot of hits. There's a ton of hits for database. But what I found was a systems administrator who was basically telling his internal team where the location of their internal KeyPass database was, along with the key for accessing the KeyPass database on the network. And sure enough, they didn't have two-factor on that for some reason. They basically just put a key and a directory on the network with the KeyPass database. Downloaded it, opened it up, all the passwords to anything you would ever want on a domain. All the SA passwords, all the databases, all the network device passwords, the pretty much all the local admins, everything. I mean, it was ridiculous. But searching through email for one term, got that. So yeah, privilege escalation with the self-search function. Next, the larger searching everything function I call invoke global mail search. Searches through all the mailboxes on the domain for specific terms. Like I said, what you need is you have to have what's called the application impersonation role on Exchange. So having an Exchange admin connect to Exchange, you grant your own user the impersonation role. You now have access to search everyone's email. And it's all it's in my script. So basically gather all the mailboxes from the domain and start searching through them and write it out to a CSV. In testing so far, we did a domain that had about 2,000 mailboxes in about 4 hours. So not too bad, time-wise. I mean, 2,000 is a good number. So yeah, that's pretty much it. So it's on GitHub here. It's available now. There is a blog post that we are releasing in about 15 minutes, and yeah, it's okay. Yep. Questions?
What's this look like in audit logs? Is this fairly noisy, or is it just look like standard EWS calls?
It's standard EWS calls for just the part where it's searching the email itself. So, all right, in order to give yourself the application impersonation role, I'm actually using PS remoting to connect to Exchange, connect with the Exchange admin credential, granting the application impersonation role on Exchange, and then from there it's all just EWS calls. Yep. Other questions? Yep.
Is there any cleanup that's needed afterwards? Like once you grant that impersonation role, does it invoke it afterwards?
Yep, yeah, so I added that in. The very tail end, it removes the impersonation role. So ideally, what you would do is run it as your typical user that you've been provided access to, which is generally just like a normal domain account that means nothing, right? So you connect to Exchange with the Exchange admin creds, but grant it to your user who you don't really care about. Like if something was residual, it wouldn't really matter, and you're not going to remove something accidentally from somebody who was supposed to have that role. But yeah, I mean, it automatically will clean up at the end of the script. Yep. Any other questions? Jeff, you want to close this out?
Yeah, sure. We got a question right here.
Oh, all right. Yep.
Is granting that access log?
I would imagine it is. I have not tested it, but we can definitely check it out. Yep.
It could be alerted on.
I would imagine it can. Yes. I mean.
But at the same time, if you already have a domain administrator, you can pivot over to an account that already has that access and run it from that account as well.
Yeah. Well, so if you have domain admin access, you can just add whatever user you want to Exchange admins at that point. So you could add your own user to the Exchange admins group, which of course would probably generate a log. Giving yourself a new AD group, right? So, John.
Any other questions just generally on the content? My part, Derek's part, any of it? Yeah, question?
When you're doing the self-search, it's going to look very different than a normal user using like their Outlook or OWA. So wouldn't that be a really good way to detect somebody searching someone else's mailbox? Yeah,
so the question was, when you're doing a self-search, isn't that going to look like any other user searching their mailbox? And I think the last part was, wouldn't that be a good sort of generalized way to audit things? Is that, that paraphrasing?
Like, normal users are going to be looking at their email through Outlook.
Right.
They're looking at their email through PowerShell. That's going to look different, right?
Yeah, so it's actually like it's using Exchange Web Services, which is all HTTP requests. So you're going to see HTTP requests to Exchange itself, which that is actually something else that we haven't actually 100% verified yet, but we have something very interesting we might be able to completely verify tomorrow or Tuesday in regards to how you connect to Exchange using web services and being able to access your own email.
Outlook for Mac uses EWS anyway, for externally, whatever.
For externally. So what we're kind of on the path of finding right now is that, so if you have two-factor enabled on your OA portals, right? A lot of organizations have that. What we're finding is that that two-factor mechanism is strictly locked down to the OA authentication itself, not necessarily all the other services like web services. So we're still need to validate it, but as of right now, we think that you possibly can bypass OA's two-factor authentication by connecting with Exchange Web Services, which this tool will do right now.
Yeah.
Yeah. Oh, okay. Validated.
It really was validated.
It says yes.
I don't know with this tool, but we've had clients just lock it down.
Log Exchange Web Services down?
Yeah.
Okay.
No external access for AWS.
Gotcha.
You want in, you VPN.
Okay.
Any other questions? Yes, sir.
On the pen test story, you said, oh, the most common password was this thing with one. What was that password again?
The most common password is company123, I believe, was the...
Yeah, but what was the company?
We're not answering that question.
Answer the question!
The seasons work very well also.
The right answer is all of them.
Hack all of the things, right? Any other questions? Yes, sir.
You dealt with the Java serialization on like Google Web Toolkit applications. How do you deal with like kind of reverse that back with Java?
So the question was, have I dealt with Java serialization on Google WebKit applications? Is that correct? I have not at this point, but I don't imagine that it's going to be any different. Sometimes the serialized objects might be base64 encoded or other some sort of custom encoding and going across the web, across the wire. Certainly there might be a second step involved there, but the concepts are the same underneath. When they're deserialized, they're just deserialized into objects, right? So the defense is if the developer is appropriately creating a hierarchical class out of read object or write object and putting additional method checks in there to make sure that they're only deserializing what they intend to deserialize, as well as doing the normal things with proper session handling and all the other things you might associate with a typical web application, then you're going to be able to appropriately defend, right? Does that help? Yeah. Any other questions? All right, great. So really the take-home message here, just to close this out, is if you want to be really good at pen testing in this industry and defending, frankly, go out and learn a programming language, okay? That is a big deal. Learn how to script PowerShell in the Windows world. Pick up any other language of choice, either in the Windows world or not. I highly recommend Python, but I do teach Python for pen testers, so I'm a little bit biased, okay? But learn the innards in the Windows domain world of the .NET framework and all the languages that connect to it. Spend some time doing that. It can be C#, it can be PowerShell, it can be a combination of C# and PowerShell. PowerShell wrapped inside of C#, right? There are all kinds of things, and there's been talks here all week that reference that. This is how you go deeper. This is how you take things further, and this is how you get away from traditional methodology and get actually where you start to provide real value for your customers. Real value in terms of emulating real threats, okay? That's what's got to happen. So here's our contact information. Please, by all means, visit us on the web. There's our Twitter handles, and we'd love to hear from you. We'll absolutely respond to any questions or further comments. And thanks very much for having us.